Ron, Joanne, and Richard. What do you guys have in store for us today?
Hello, I'm Ron. I'm a backend developer mentor, and right now I'm currently working at Brain Test, which makes a scientifically validated cognitive test to help patients diagnose Alzheimer's and cognitive decline.
Hi everyone, I'm Joanne. I'm a dev mentor with Game of Apps, and this is my first year with the group. I'm currently a software engineer at Cisco. I'm working on a platform for testing and verifying all Cisco hardware products before they ship.
Hello all, my name is Richard. Nice seeing you today. I work as a software engineer at Google by day. I make Pixel phone that's loved by millions of users around the world. And by night, Tuesday night specifically, I'm a Game of Apps mentor. All right. So here today, I actually have a problem that I need you guys' help. So guys, the problem here is that I have too many walks and I really need to organize them. Otherwise, Justin is going to keep talking about my walks in season 6. So I need help. Please help me organize my walks. I would like to sort my walks from the smallest to the largest, but I don't know how to do it. So guys, I need help. Can someone help me figure out a way to do this?
Well, one way to go about sorting these walks is called selection sort. So basically, you're going to sort your walks by repeatedly finding the smallest walk from your top rack, that unsorted part of your collection, and adding it to your bottom rack.
Okay.
So, to find the walk.
That's a small. So I guess I'll start from this. So this, we have one walk. If we go to 2, which one is smallest here? I guess this one is smaller.
Yeah, it looks like the second one's smaller. Yeah.
So if we try to go one more, is this smaller? Which one is smaller among these 3? I guess this one's still smaller.
Yeah.
Still the second one.
Okay. So if we keep going, this one is still the smaller. And then if we look at all 5, this one is small. So I guess this is the small spot currently among the selection. So I should take it and put it on the bottom rack. Is that right?
Yeah.
Yep.
Okay, so that's one. So what do I do next? So it seems like one walk figured out, but what about the others?
Yeah, so you repeat the same process. You look at your top rack of unsorted walks still, and then you try to find the smallest one.
This one is 1. Among these 2, this one is smaller. If I look all 3, this one's still the smallest. If I look all 4, the remaining, this one is still the smallest. So I guess I'll just do what we did earlier again. I'll just take this walk and put it on the bottom. And this is, we now got 2 walks figured out. So let's see. So do we just keep doing the process again until we see all 5?
Yeah. Just do all of them until all the walks are sorted.
1, 2. This is smaller. So this is the smallest one. If we look at all 3, that is smaller. So we take the current smallest one, and then we'll put it on the bottom rack. So now if we see 2. So now if we see these 2, this one is smallest, so we'll take this and then we'll put it on the bottom. And now if there's only 1 left, I guess we'll just take this and put it on the rack. All right, so looks like all my walks are sorted from the smallest to largest. This is the smallest, second smallest, the middle, second largest, and largest. Cool. Thank you, Joanne, for helping me figure out this. I wonder if you could show us a little bit more insight on how this worked.
Sure. Can someone bring up the first slide? So basically, this code sample sorts the. So how we did it, how Richard did it was he organized or sorted his walks by having 2 arrays, so a top rack of unsorted walks and then a bottom rack of sorted walks. In this code sample, actually, it's sorting the walks in place. So basically, the outer for loop keeps track of the current spot you want to find the smallest walk for. And so you're going to sort for the first spot, then the second spot, and so on up to the second to last spot. And in the inner for loop, you're basically comparing you're comparing the walk at the current spot to all the walks to the right of it. And what you're trying to find is the smallest walk amongst all of them. And so after finding the smallest walk, you would perform a swap to get the smallest walk in the current spot that you were trying to sort for, and basically the walk that's in the current spot would be swapped to where the smallest walk used to be. And so after doing it for in one pass, you would repeat this process for finding the second smallest walk for the second spot, third smallest walk for the third spot, and so on up to the second last spot to sort all the walks. And so yeah, that's basically how selection sort works in code.
Thank you, Joanne, for explaining. So it seems like now I got a new problem. So I still got these walks that are on here. They are in random order. But the thing is, my bottom rack is full. Like I have stuff on it, so I cannot really use the second rack for storage, temporal storage for sorting. So it seems like I need help again on how do I rearrange these walks now that I don't have much space to work with.
All right. Well, I think I have a better solution, and we call it walk sort.
Ooh.
So let's give this a go. So what we're going to do is we're going to actually just look and compare the walks, two walks at the same time. And if one of them is smaller, then you want to basically swap them.
Okay.
Yeah,
so do I start from the left side as well?
Yeah, exactly. Let's start from the left side as well.
So if I compare these two, it seems like this is smaller. So does that mean I swap them?
Yep, that's right.
All right. So I'm not using any extra space, just the current space that I have. Okay, what do I do next?
Okay, so now we know that the first one is obviously smaller. So now we look at the second and third walk. Yeah, exactly.
Okay,
and now
so
we also see which
this is smaller, so I swap them again.
Correct.
Okay, so now I just repeat the process and keep going.
That's right, until you find a walk that's smaller.
This one is smaller, this one's larger, so I'm going to swap these two.
Yep.
Okay, now I look at the last two. See, based on Ron's algorithm, so this is bigger, this is smaller, so I'm going to swap them again.
That's right.
Okay. So it seems like we went through a round of swapping. Do we have to go again?
Yeah. So let's start from the beginning again and see if you have to continue swapping.
Okay. So it seems like if we look at the first two, this is already smaller. So it seems like we don't need to swap it.
Yeah. So let's move on.
So look at these two. This is already bigger than this, but it doesn't seem like we don't need to swap it.
Mm-hmm.
Okay. Then we look at these two. Well, this one seems wrong because this is smaller and this is bigger. So it seems like we should swap these two again.
That's right.
Okay. Now with the last two, this is bigger, this is smaller, so this is okay.
Yeah.
Okay.
And so looking at it right now, it looks like we've got a sorted walk array.
Wow, small. Yes, you're exactly right, Ron. This is actually looks sorted. Thank you so much for your help. And I didn't even use up any extra space. I only used the existing space and just kind of swapped them. I was wondering if you can walk us through how the code works.
Yeah, for sure. So let's bring up the second slide. All right, so this one is slightly different from the first algorithm we used, but it's quite similar. But the big difference is that we don't need to create a second array to store the walks temporarily. So we just do everything in place. And what we want to do is basically we just go in and compare and check to see that the elements are, if they're smaller, then we do a swap. And if not, we don't. And then we basically increasingly move along the array until we know that we have a sorted array. So in the worst case scenario, we could be doing a lot of work, but because we have a basically reverse sorted array already. So, you know, from largest walks on the left to smallest on the right. So we could end up doing a lot of work, but in the average case, most likely you won't have that scenario. So we just like today, we only did a couple swaps. So it's a little bit quicker. So yeah, that's how we walk sort.
Thank you, Ron, for walking us through the code. This is us proving to Justin that not only can I talk the talk, I can also walk the walk.
Wow, Richard. I see you got your walk sorted. I still think you need just one walk in life, not 5.
Or maybe I'll get 6 walks for season 6.
All right. Thanks. And we'll pass the time back to Janice.